Uh, Good afternoon, everyone. Today we'll discuss alkenes. Alkene, as we know, if between the carbon and the carbon there's a double bond, we call alkene, and the name should end at ene. How we form these alkene, formation of alkenes. How we form alkene by cracking off long chain hydrocarbons. So by cracking of a long chain hydrocarbon, we can form these alkenes. And what are the products of a cracking? As we discussed, if we have a long chain hydrocarbon, when we supply heat energy in the presence of the catalyst, it may form either alkane or alkene, or this may result in a formation of alkene and hydrogen. So these are the two possibilities. So both cases you can see when we do cracking of hydrocarbon, long chain hydrocarbon alkanes, as a result we will get alkene, an alkane or alkene or hydrogen. Yeah, we discussed this already, but this is first I explained the cracking, but in this is a topic how we form alkenes. So how we obtain or form these alkene is by cracking of long chain hydrocarbon. I'll not go in detail right now, as already we discussed this topic. So if a question is how you can form alkene or how alkene is formed, is by cracking of a long chain hydrocarbons. Then reactions of alkenes. The first reaction, number one, is combustion, because these alkenes can also be used as a fuel, so we can burn them in the presence of oxygen. This will result in a formation of carbon dioxide and water vapor. So alkene plus oxygen gives, if a complete combustion is there, this will also result in a formation of carbon dioxide plus water vapors. Because these are hydrocarbon, that's why whenever you burn them, this will always result in a formation of the water vapors. And for balancing this equation, always remember the combustion equation. You will start with carbon, followed by hydrogen, and at the last, oxygen. That's the order to balance. So if I have alkene, if C3, how many hydrogen should be there? If it's an alkene, because in alkene, the general formula is CnH2n.
Six.
It should be 6 because the number of, it's an alkene. Alkene have number of hydrogen twice as compared to number of carbon. So twice of 3, that's equal to 6. So number of hydrogen should be 6. Reacted with oxygen. When you burn in the presence of oxygen, this will result in a formation of CO2, carbon dioxide, plus H2O or water. Now the balancing part, you always start balancing with carbon, followed by hydrogen, and at the last, other element. Combustion means burning. When you burn these alkene, it reacts with oxygen, give carbon dioxide and water. Yesterday we also did the same thing for alkanes. So alkane burns completely, that will also give carbon dioxide and water, because both alkenes and alkanes are hydrocarbon. The term hydrocarbon means they contain carbon and hydrogen. So whenever you try to balance this equation, you'll start with carbon. On the left hand side, you have 3 carbon. How many carbon should be there on the right hand side? It should be 3 as well. So we put 3. Carbon number is balanced. For hydrogen, we have 6 hydrogen on the left hand side. So we should have 6 hydrogen on the right hand side. So we put 3. So 3 multiplied by 2, that also makes it 6. Now to balance oxygen number, 3 multiplied by 2 is 6. And this 3 is with oxygen, so 6 plus 3, that's make 9 oxygen. 9 oxygen on the left hand side, I need 9 oxygen on the right hand side. So what I can do, I can write 9 by 2. Because this 9 by 2 multiplied by O2 will give 9 oxygen. Is it clear? This is a balance equation for combustion of alkene. So formation of alkene, if we want to form alkene, we do cracking. Cracking already we discussed. And if we want to burn them, the reactions of alkene, number 1 is combustion. CnH2n is a general formula of alkene. It means the number of the hydrogen are always twice as compared to number of the carbon. Like if there are 2 carbon atoms, there should be 4 hydrogen atoms. If there are 3 carbon atoms, there should be 6 hydrogen atoms. If there are 4 carbon atoms, there should be 8 hydrogen. That's a general formula. CnH2n, what does it mean? It means the number of the hydrogen are twice as compared to number of the carbon. Is it clear? Copy this part. So first we started the introduction. I finished all the topics like the overview, but now in detail you will study in detail about alkanes, alkenes, alcohols, and carboxylic acid. So first one, alkane, we are done with alkane. Now we are doing alkene. Then after this will be alcohol, and then a carboxylic acid. Finish writing this?
Yes, sir.
it's an order for balancing the equation. CHO, you start with carbon, followed by hydrogen, at the last oxygen. So example, if you want to balance another equation, if it is C5 or C4 and H8 plus oxygen or O2, this result carbon dioxide and H2O, which is water. Yesterday also I gave you the explanation that the order of balancing for combustion equation start with carbon, followed by hydrogen, and at the last oxygen. That's the order to balance these equations. We have 4 carbon on the left hand side, so we should have 4 carbon on the right hand side. So we put 4, so carbon is balanced. Then 8 hydrogen, 4 are 8. We need 8 hydrogen on the right hand side, so we put 2, hydrogen is balanced. Now to balance oxygen, 4 multiplied by 2 is 8, and this is 4. So we have total 12 oxygen on the right hand side. We need 12 oxygen, so we put 6. So oxygen number is balanced as well. Is it clear? So we start balancing with carbon, followed by hydrogen, and at the last oxygen. So if you want to balance another equation, say C6 and H12, and it reacted with oxygen, which is O2, the complete combustion result in a formation of carbon dioxide and water, H2O. So we have 6 carbon. So to balance these 6 carbon, I will put 6. To balance hydrogen, we put, because we need 12, so that's why it is 6. And for oxygen, 6 multiplied by 2 is 12, plus 6, 18. So we need 18 oxygen on the right hand. We have 18 oxygen on the right hand side. We need 18 oxygen on the left hand side. So 9 multiplied by 2, that will give us 18 oxygen. Is it clear, this balancing? This is just an example, more examples related to balancing equation. So the first reaction is combustion reaction for alkenes. Then the second type of reaction is known as addition reaction, and it can have addition reaction with many things. So when alkene react with any substance, what will happen? They have addition reaction. Addition reaction means you have only one product. And when alkenes react with other substances, the double bond will change to single bond, and it will form one product. I will give example how this happen. So addition reaction means when two substances are there, they react, and the product is only one substance as a product. We call that as addition reaction. So first example of addition reaction is with hydrogen. So if I draw an alkene, C double bonded with C, what is the name of this alkene which contain two carbon atoms? What is the name of this alkene which contain two carbon atoms?
Propane.
Two carbon, two. For two, what we use the term? What is the suffix used?
Ethane. Ethane.
Prefix used for two, it's eth. Because there are two carbons, so it is eth. And because they have a double bond between them, so it is ene. So it is ethene. Now, it reacted with hydrogen. Hydrogen means H2. So I can write H and there's another H. How the reaction will occur when alkene react, initially they have a double bond. But when alkene react, the double bond will break. The double bond will become single bond. So as the double bond will break or double bond will become a single bond, now, as we know, the carbon can form how many bonds? Carbon can form 4 bonds. So right now, when the double bond breaks, now this carbon, each carbon can form 3 bonds. So what happened? One of the hydrogen attached to the first carbon which break the bond, and the second hydrogen attached to a second carbon which breaks the bond. So what happened? What will be the product? You have C this was original ethene. There was a double bond between the two carbon atoms. So the double bond will break and the two hydrogens form a bond with each carbon. So what is the product here? So ethene plus hydrogen, what is the product? Product contain a single bond. So if a product contain a carbon-carbon single bond and there are two carbons, so what we call that as it turned into ethane. So in alkene, there is a carbon-carbon double bond. When it reacts with hydrogen, the two hydrogen atoms added to the alkene molecule. So the double bond will break and it turn into a single bond and the product will turn into alkane. So if we generalize this equation, we can say alkene, any alkene plus hydrogen will give alkane. So the double bond will break and it will turn into single bond. And as a result, what you will have alkane. In exam, they may give you the structures or sometime you have to just complete the equation. Ethene means, if I write in terms of molecule, eth means 2 carbon for the prefix, and because it's an ene, so number of hydrogen should be twice. So C2H4 plus H2. So C2H4 plus H2, what will be the result? The result will be C2 and H6. And why we call this as an addition reaction? Because you can see we have more products, we have more reactant, but we have only one product. So a chemical reaction in which there are more reactants and only one product is there, these type of reactions are categorized as addition reaction. Is it clear, this idea? I'll give more examples, but this is a basic idea that what happened When alkene
Sir,
react,
I didn't understand the part where the double bond breaks to.
because what happened, for a reaction to occur, there is a carbon-carbon double bond. That's an alkene. But when the double bond will change into carbon-carbon single bond, so two carbon atoms can form the bond with hydrogen.
No,
As it,
how does it change? How does it change?
because the temperature is around 200 degrees centigrade, and we use a catalyst nickel for this purpose. So that high temperature causes this bond breaking. The reaction condition, high temperature around 200 degrees centigrade, and nickel as a catalyst used so that the bond can break in alkene and it can turn into single bond. Is it clear? So whenever alkene react with hydrogen, it will result in a formation of alkane. I'll give more examples. First copy this one. So if they ask what are the reaction conditions, so what are the reaction conditions? We use high temperature, which is around 200 degrees centigrade, and we use nickel as a catalyst. Condition for or use of a catalyst, we don't write the catalyst in either reactant or product, because catalyst is a substance which alter the activation energy or speed of the reaction. So it does not take part, or chemically it does not used up in the chemical reaction. That's why you don't write catalyst on reactant or product side. You just write the name of the catalyst on the arrow.
Sir, if we didn't use a catalyst in the reaction, will it still work in high
Yeah,
temperature?
but it will be very slow. So purpose of the catalyst is to speed up the reaction. Absence of the catalyst, the reaction rate will be very slow. That's why we use, to speed up a reaction, we use a catalyst. And when in this, we are adding a hydrogen. So when we are adding a hydrogen, we also call that as hydrogenation. The term hydrogenation means addition of hydrogen.
Sir, oxidation happen in this reaction?
The term oxidation is addition of oxygen or removal of hydrogen.
So,
no, the term redox reaction, here it's called hydrogenation. Rather than you classify the reaction as high oxidation or reduction, addition of hydrogen is there. And in terms of hydrogen, there is another definition for oxidation. In terms of oxygen, there is a definition. In terms of oxygen, addition of oxygen is called oxidation. Removal of oxygen is called reduction. And in terms of hydrogen, addition of hydrogen is called reduction, and removal of hydrogen is called oxidation. Another example for this, say you have instead of showing all the hydrogen bonds, I will just show carbon-carbon bonds. So CH2, double bond CH, double bond CH3. Can you identify this alkene? What's the name of this alkene? What is the name of this alkene? 3 carbon atoms. And the double bond with the first carbon. 3 carbon atoms, so we say prop. So prop is for 3. And ene because they have a double bond. It reacted with hydrogen. Hydrogen means H2. I can draw in this manner, H2 I can write, or I can write H single bonded with another H. So when a reaction occurs around 200 degrees centigrade and nickel as a catalyst, hydrogen is added, the first hydrogen added to the first carbon which is having a double bond, second hydrogen added to a second carbon which is having a double bond. So what will be the product? First it was having 2, but now it will have 3 hydrogen. So it will be CH3. The double bond will turn into single bond. It will CH2 and CH3. What is the name of this compound? What's the name of the product which is formed?
Propane.
Propane. So the product is propane, and it is obvious that the alkene should convert into alkane when they react with hydrogen. And in terms of molecule, like if I write the formula C3 and H6 reacted with hydrogen, hydrogen is H2. Then C3H6 plus H2 will give C3H8. And it's easy to learn this equation because it's an addition reaction. So it can, on the left hand side 3 carbons, so on the right hand side you should have 3 carbon. On the left hand side total 8 hydrogen, so the final product should have 8 hydrogen. So propene plus hydrogen will give propane. Is it clear, this example?
Yes.
Same way, if you have another, if double bond is not present with the first carbon, the reaction will occur in the same manner. So CH3, CH, double bond CH, CH3. Can you name this hydrocarbon alkene? What's the name of this alkene? So when double bond is not with the first carbon, you have to, there are 4 carbon atoms. For 4 carbon atom, how it will be meth? For 4 carbon atom, it should be but. But the double bond is not present with the first carbon. The double bond is not with the first carbon, so you have to number these carbon 1, 2, 3, 4. So double bond is coming with the second carbon. If I count from right hand side, the double bond is with the second and between second and third carbon, or I can simply say second carbon, which is closer. So both ways the double bond with the second carbon. So that's why it is but-2-ene. But is because of 4 carbon, 2 is the position of the double bond. Any one of the numbering you can follow, either from right to left or left to right. It does not make difference. If it react with hydrogen, hydrogen is H2.
Sir, the 2 is for the
Position of the double
position.
bond.
Yeah.
Position of a double bond. So it's butene because the double bond with the second carbon reacted with hydrogen. So hydrogen will be added. So what will form? It will form CH3, CH2, CH2, CH3. What is the final name of the product? What's the final?
Butane.
Butane. So this
Sir,
is,
then one question.
yes.
Then in the branch part, this one butene, wasn't this only for branches, like
No,
the
this
positioning?
is for alkenes. Alkenes, straight chain alkenes may have different position of a double bond. The double bond position may vary. So for straight chain alkenes, you have to specify if it is with the first carbon, like why I did not name this first one. I did not say prop 2-ene or prop 1-ene. Why? Because the double bond is with the first carbon, like between first and second carbon, but in terms of numbering, it's with the first carbon. That's why we don't have to write the position. But if double bond is not with the first carbon, then we have to write the name or the position of the double bond. We have to include. That is in, this is the part in alkenes topic, straight chain alkene.
Okay, sir.
Okay. So the result will, so butene react with hydrogen, it will result in a formation of butane. And the reaction is called addition reaction. Why? Because there is only one product. That's why we call addition reaction.
Sir,
Yes.
I'm done.
Finish, done. Okay. So sometime you have to complete a word equation. Sometime you have to complete a word equation. Sometime you have to complete a symbolic equation, and sometime you have to draw the structure of the product. So example, if they say butene plus hydrogen, what will be the product if butene is added to hydrogen?
Butane.
So the product will be
Single bond butane.
butane. Sometime you have to complete the symbolic, like they may give C5H10, which is pentene, reacted with hydrogen. What is the product?
Pentane.
Yeah, but then in terms of yeah, the product is pentane, but you have to draw the structure, like the molecular formula of pentane you have to write, so it will be
C5H12.
H12 will be there. And sometime the structure is given, they give you the structure, like example, if I give structure of propene or ethene example, it reacted with hydrogen. So the product, the double bond will break into single bond, and the two hydrogen atoms added to a carbon which are having a double bond between them, that will be the product. So the question can come in different manner, sometime completing a word equation, sometime completing a symbolic equation, and sometime you have to draw the structure of the product, but all are using a same concept, same idea. And reaction condition, you have to memorize. The reaction condition is around 200 degrees centigrade in the presence of nickel as a catalyst. This is one of the addition reaction. There are more addition reactions of alkene. This is the first kind of addition reaction which we call hydrogenation. The term hydrogenation means addition of hydrogen. I'll share another link once this will end. It's less than a minute left.